This one focuses on curvature and the normal vector n, how to get it. Since the unit tangent vector has length 1, we know that its derivative with respect to s is orthogonal to the vector itself. So t and dt ds are orthogonal. Well, what does that mean? Well, in picture form, that vector right there is r, it's our position. This vector right here, vector that's 1 unit long, happens to be t. Well, t is changing, and the way it's changing is it's turning that direction, so it's turning down a little bit as we move, which means that the derivative of it is going to point down. So if I want to draw the derivative of t at this point, that vector right there would essentially be the direction for dt ds. If I enter a spot where it turns more sharply, here dt ds, if that's t, dt ds is longer because the curve is changing more rapidly. So the length of dt actually is directly related to how quickly the curve is changing. So we can put that down as dt ds is long when the curve is rapidly changing direction. This vector, dt ds, we're going to give a name. We're going to call it the curvature vector. dt ds is the curvature vector. If you actually want to calculate it, remember, anytime you see a ds, just divide the numerator and the denominator by dt. So this is really just t prime over, and remember ds dt is speed. The length of this vector is called the curvature. This is called the curvature vector. And the curvature is given, just denoted with a k or a kappa without a vector on the top. The larger kappa, the more quickly the curve changes. Now, if you want to get the normal vector is a unit vector, so just take the curvature and divide it by the length of it itself, and that will give you the normal vector. Now, another comment to note is that the t prime vector happens to point in the same direction as the curvature, so I could just calculate t prime and then divide by its magnitude, and I'll get n as well. Let's look at an example. We'll take r of t equals 3 cosine t, 3 sine t. So let's go with a circle of radius 3. Its derivative is negative 3 sine t, 3 cosine t. The speed, the length of that vector, in this case would then be 9 sine squared plus 9 cosine squared, which is just 9 times sine squared plus cosine squared, or the square root of 9, which is 3. So if I want to get t is, take this vector, negative 3 sine t, 3 cosine t, and then divide by 3, which means those disappear. So if I want to now find dt, or t prime, let's just take the derivative here, which is negative cosine t, negative sine t. The magnitude of this vector is square root of cosine squared plus sine squared, which is 1. So if I'm after the curvature vector, the curvature is t prime over speed, which in this case would be negative cosine t sine negative sine t over 3. The curvature vector's length, which is the curvature, would just simply be the length of this vector, which, well, the length of this is 1, so if this is 1/3. And if I want the normal vector is found by just taking t prime over the magnitude of t prime, which in this case is negative cosine t, negative sine t over 1. That completes this one.